Good morning, good afternoon, good evening, everyone, for taking time to join us. My name is Arun. I'm Principal Analyst within the Aerospace and Defense Division at BIS Research. I'm here with my colleagues Amy Gracia and Nilopal Oja, Ahmed Shakib, Bhavya Banga. And we are greatly thankful to Mr. Daniel Feber, Chief Executive Officer of Orbit Fab, for joining us to co-present along with us in this webinar. uh, you know, we are going to discuss about the in-orbit refueling market. Uh, you know, Frankly, 3 years ago, if we have had an internal discussion on this topic, we would have thought more than twice to even consider such a discussion, because the very idea of going to orbit and then refilling an empty satellite's a propellant tank and then extending its mission would have sounded so outlandish. However, what has happened in the past few years is that many companies, Orbit Fab included, have made great innovations, great strides in that direction. And as of now, this market is operational. We have had quite a few successful use cases of non-cooperative mission life extensions. And we are absolutely stunned and thrilled, and that's what has brought us to this topic, in-orbit refueling. How is the in-space economy evolving, and where does in-orbit refueling sit within the larger scheme of things? What are the opportunities that are emerging out of these, and what are the challenges, and how are the participants in this market planning to solve those challenges? That's what we are going to go through in this webinar. To give a brief introduction about Mr. Daniel Feber, he has over 2 decades of experience in space innovation leadership. A very experienced professional, a serial entrepreneur. All the way from commercially, successfully commercializing a water-based satellite thruster to securing over 100 million contracts for in-orbit refueling, including government and commercial customers. He has had a stunning career so far. So we are very much happy to have him on board with us on this webinar. We can get started. And joined with us is my colleagues Nilopal Oja and Amy Gracia, and they are the lead analysts within the Aerospace and Defense Division. And pretty much any aerospace defense security robotics study that gets published at BIS Research, those reports go through these two, and they will also be presenting along with us. Now, the agenda for the discussion is, from BIS research side, we will take you through our observations of what the in-space economy looks like, what how we see in-orbit refueling, within the scheme of in-orbit services, and what are the different segments of it, and how in-orbit refueling seems to be the most significant piece of it. And then we would go over the trends, the key developments that we have observed in the recent past, and then we will discuss the challenges and the key capabilities required to make these things possible before handing it over to Daniel Feber, so he can explain how Orbit Fab is planning to solve this problem of in-orbit refueling. Once we are done with our set of slides, Daniel Feber will make the presentation, and after that, we will open the floor for questions, and then we can close the discussion. That would be the agenda for this webinar. Now, to give a brief overview of where we stand with respect to our view of the space industry as such, 155 constellation operators are active, and our forecast has a little over 43,000 satellites to be launched in the 10-year period, 2022 to 32, and a little over 7,000 of those are going to be from the Earth observation application. And we are talking thousands of satellites to be launched, and some of them are going to require deorbiting services, some of them are going to require in-orbit inspection, repair, replacement, and clearly some of them are going to require in-orbit refueling as well. And with these mega constellations going through their initial installation, there is their imminent replacement and expansion phases. We are looking at many more thousands of satellites going, being installed in the orbit. Credits to the new space market for growing so exponentially against a lot of skepticism. And the in-orbit services segment as such, we see as a natural consequence of this growth of the new space market. It's more of a pull from the end users, the customers, rather than the push from the solution providers. And we are going to focus on refueling and life extension in this discussion, but we will also go through the inspection, repair, replacement elements of it. They are all closely connected, although they sound very different. And like I said, credits to Northrop Grumman's subsidiary Space Logistics for successfully demonstrating more than one use case of in-orbit refueling. In this case, it is life extension missions where the refueling satellite went to orbit, got itself attached, physically to the target satellite, and it has performed station keeping burns, and it has brought back the mission to life. And it is non-cooperative at this point because those target satellites are not designed to dynamically participate in this activity, any sort of in-orbit service activity. And the way we see it, it is going to remain, most of the in-orbit service operations are going to remain non-cooperative in the short term, but with relevant support hardware and software being installed across spacecraft, and with the satellite platforms being standardized, we do see the shift from the non-cooperative version to the cooperative version of missions moving forward, in which case the in-orbit refueling market will also scale up and it will also grow. And this is not just restricted to Earth orbit missions the way we see it. And quite frankly, we did not expect deep space missions to be a strong source of demand for this, but as it turns out, many deep space missions, both the initial expansion and the recurring phases of them, are going to rely on in-orbit services, the refueling piece being one critical one element of it. At this point, I would like to hand it over to my colleague Nilopal Oja. Over to you, Nilopal.
Sure. Thank you. Thank you so much, Arun, and welcome everyone. So now, as Arun already mentioned about the overall space ecosystem and how many satellites are currently orbiting and what sort of satellite constellation. So just to start from there, so now more than 6,000 satellites are there in space as of now, and we have launched more than 12,000 objects into space. Now this is the number till 2022, till the beginning of 2022. Now going forward in next 10 years or so till 32, we are expecting 40,000 more satellites to be launched into various orbits, majorly into the LEO orbit, but also the other orbits that are GEO and NEO orbits as well. So now most of the upcoming satellites are part of mega constellation for the lower Earth orbit, and there are more than 150 satellite constellation currently existing, and they are most of the satellite constellation are in expansion mode, and majority of them majority of the constellation are either dedicated for communication or earth observation, or either they are planning to have those services going forward. So now majority of the mega constellations are like the major operators who are operating in this mega constellation are SpaceX, OneWeb, Planet Labs. Those sort of companies operators are looking to expand their existing satellite constellation as well. So OneWeb have done their completed their first stage of all the satellite launches, and now they are planning for the second stage. Now, having said that, the satellite operator are constantly expanding their satellite constellation. So just to have that, when we are talking about constellation, we are talking about the multiple satellites that are there in orbit. So now, just to handle those volume of satellites in orbit, the in-orbit servicing will and refueling will be playing a major part, along with life extension, inspection, repair, and replacement. So now there are various companies that are supporting this activity from the in-orbit servicing ecosystem. Now talking about that in-orbit servicing, it is divided into several parts. Now we will be focusing on the refueling and life extension part, as well as the inspection, repair, and replacement. So refueling and life extension is the service that refers to the extending the operational life of the satellite by attaching a propulsion service satellite, or or to the back of the satellite customer satellite which is there in orbit. or the other part is the refueling. Refueling refers to the providing additional propellant for this satellite to extend the mission life of the customer satellite. So now what? Now from the point of why we are having that need for refueling and life extension is the major drivers are the life extension for the satellites that are there in geo orbit. So now most of these satellites which are there in geo orbit, they are not completely utilized. So now I'm from the completely utilized standpoint, it is like they still have the service life remaining for more 5 years, 3 to 5 years, and they are not able to operate just because they have run out of the fuel. So now additional return on investment is what these operators are looking for, and refueling is the most suitable way that they can have that return, because launching a new satellite will again be very costly affair, and you already have a set that is operational in the orbit, like it can be operational in the orbit, so that can be utilized. So now the demand, why it is having that demand, is to have that life extension to avoid more satellite debris. Now once we discard a specific satellite, that becomes a debris, like it is orbiting the earth without any purpose. So now life extension provides that extended life for the satellites, and it is more, as I mentioned, it is more cost effective as compared to launching a new satellite. Yeah, and you can have it in lesser time as well. So now the and apart from it, refueling also helps in the actual, like when we are launching a particular satellite, we don't need to carry that extra propellant while launching from the earth itself. So now we can have, like once we have the gas station in space, as orbit fab is moving towards that part. So now the operator don't need to carry that extra fuel on board, so it reduces the overall weight, and it reduces the launch cost as well. So now the other part wherein we were talking about the different ecosystem. So now now there is a complete concept of space depots as well. So same as the gas station that you see on Earth, you will be seeing same structure in space as well. That is the next evolution for it. So now you will have a refueling depot. Apart from it, you will also have a facility wherein all the components, whatever it is required for your specific satellite, either it's a replacement of a component, you can collect that from that facility as well in space. So now that now those space depots can be helpful for space stations, satellites, that they can work smoothly. So now assembly, manufacturing, inspection, repair, all those can be facilitated with that. So now in space depots will be helpful in providing those commercial space station long-term deep space missions, a recovery and use of the space hardwares that are actually in space. So now the abandoned satellites that can be collected, we can collect their components and can be stored for further use as well. So now that becomes a complete ecosystem. So now from the overall perspective, now with the increasing number of satellites in orbit for different constellation and satellite operators, now they are looking for more return on investment. Just to summarize, so that they can create a huge potential for the in-orbit servicing market. Now that creates a huge potential, and as these assets are currently in geo-orbit, they once they are refueled, they can provide a better, like have a extended life and provide a better service. Now to talk about the other aspect wherein the inspection, repair and replacement, I would like Amy to provide that input. Over to you, Amy.
Thank you, Nilopal, for sharing your thoughts on in-space refueling and life extension services. Now we will be talking about the other in-space in-orbit services, which includes inspection, repair, and replacement. Now, these in-space services are in-space capabilities which will help in maintaining the overall technical functionalities of any space assets, whether that is satellites or the International Space Station or the upcoming commercial space stations. For instance, the satellites operating in geo orbit. Now, this is one of the segment which is representing a potential opportunity for not only life extension services, as Nilopal has mentioned, but it also represents an opportunity for inspection, repair, and replacement services. Also, with the upcoming launches of a commercial space station and lunar gateway from companies and space agencies such as Axiom Space and NASA, this represents a whole new opportunity for companies providing such in space capabilities. Now, since most of the durations of space missions are long, and overall and over time, these smaller components might go through some defects. Now, there could be some unforeseen incidents happening in these missions, which might not necessarily be a system failure, but it can be a malfunction largely on the exterior aspect, or just some smaller deviations in the positioning, which the satellite cannot fully recover. Now, we have to know that these satellites do not have an inbuilt capability to repair itself. These are such scenarios. Such scenarios will lead, for in space inspection, repair, and replacement, and provide that opportunity for these key players who are operating in this ecosystem. Now, having said that, why is there a need, or a kind of a requirement for in-space inspection, repair, and services? Now, one of the major reasons for that is, though that through these in-space services, the space assets like satellites are maintained so as to ensure that there is a continuous operations and that there are no hindrances in their missions. Not only that, these in-space services includes the replenishment of expendables such as cryogens, as well as spacecraft components such as satellite solar arrays and thermal system components. Now, historically, the space industry have witnessed such in-orbit services being conducted in the past. Now, for instance, the Hubble Space Telescope was serviced 5 times, which included replacement of circuit boards. And apart from that, the International Space Station was assembled on orbit, and is continually replenished with propellant supplies and new modules to enhance its capabilities and provide new science opportunities. Now, looking into these in-space services, we need to understand, is there a demand for such services? And the answer to that is yes, there is a need for such in-space capabilities, because one of the reasons is that these services will extend the life and the capabilities of the satellites and other space systems. Now, apart from that, we are also observing that there are programs focusing not only on these in-space services, life extension, inspection, repair, and replacement, but the industry is looking at also the in space manufacturing capability. Now, for instance, Airbus, under the Horizon 2020 program, they will carry out its in orbit project, which focuses solely on the satellite assembly and the manufacturing, which will happen in orbit. Now, additionally, there's a rise in the mega constellations, and these constellations are for the objective of high speed broadband and communication, and these are being conducted by companies such as SpaceX and OneWeb. Now, such activities will present numerous opportunities for in space services. Now, looking at this ecosystem, there are several key companies which are operating in this ecosystem, which includes Orbit Fab, Infinite Orbits, the Orbit, Astroscale, Airbus, and many more. To talk more on the activities and the developments that are being conducted by these key players in the market, I will invite over Nilopal. Over to you, Nilopal.
Sure. Thank you, Amy, for the insights. So now talking about the developments, like one of the major players that is very active in this ecosystem for the in-orbit refueling is Orbit Fab. So now talking about them, we they in October 2022 itself, they have won contract for more than 13 million to provide the in-orbit refueling for the US Space Force. So now this will start from 2025. It again, this is in line with the Orbit Fab announcement in August, wherein they have announced that they will be providing hydrogen for satellites in geostationary orbit. from 2025. So now at the pricing of 20 million. So now moreover, most of the companies now are planning to utilize this service in space, and to increase their return on investment, reduce their launch costs. So there are various benefits of having such service in orbit. So if we talk about in last, like, as I mentioned, if we would have thought about this or discussed about this 3 years ago, we would have been like if we would have discussed this with somebody else, they would have laughed at us. Like this is not even possible. But hats off to Orbit Fab that how quickly they have transformed this complete ecosystem, like in orbit servicing as a whole. So they have taken everything by storm. So hats off to them. And apart from it, for the inspection, repair, and replacement, I would like Amy to shed some light on that as well.
Yeah, apart from Orbit Fab, I mean, there are other companies as well who are, involved in conducting their activities and developments in this area. And not only that, they're also, developing technologies which are enabling these in-space services. Now, looking at these other developments, we can see that, Northrop Grumman, which has already conducted their mission extension vehicle mission on Intelsat. And apart from that, we have the Starfish Space Technologies, Starfish Space as well. They have signed contracts and agreements with other space companies for providing not mission extension pods and navigation software for proximity operations respectively. Now this shows that there are several companies that are developing and showcasing their capabilities that will enable these in space service capabilities. Having said that, the industry is not is also, there are opportunities and challenges present in this industry. And to talk more on this aspect, I would like to hand over to Arun. Over to you, Arun.
Thanks, Amy. Now, getting back to the fundamentals of this in-orbit refueling, if we really have to visualize that, that's a satellite in orbit. Now, it has a certain problem and it needs to be corrected, physically. It means we need to get to that satellite first. We need to get to that orbit. We need to be in that orbit when the satellite is also there, and then begins the whole proximity operations. We need to get very close to it, and we are talking many layers of space situational awareness being deployed just to ensure the rendezvous, the physical contact, how the refueling satellite gets in touch with the target satellite and what it does to that satellite happens such that they don't end up breaking each other, and it does not cause any debris. Because if there is a crash, and even if there is a small piece of debris, we are looking at a potential cascading effect. It will not only compromise that mission, it is going to throw a whole lot of risk for multiple operators using that orbital space itself. But so that itself is a huge challenge. So the biggest requirement there is very high levels of space situational awareness, especially after the satellite has made it closer to the target satellite. And so multiple enabling capabilities, be it hardware with respect to the docking system or the refueling port. And and it needs to be matching. In a cooperative atmosphere, the target satellite will have the relevant hardware that will mesh with the refueling satellite which will be there to service it. But as of now, the same activity is being successfully conducted non-cooperatively, where the target satellite is not lending itself in any way. It is just being there, and without its participation in any way, the refueling or the servicing satellite is performing these operations. And there is this aspect of deorbiting versus refueling. We were having this view that these are two very separate things, but as it turns out, it's not the case. Now, if there is a constellation operator with a set of satellites, clearly as the satellite reaches the end of its mission life, they have to replenish it, replace it. But if for a small marginal cost, if that satellite can be refueled and it could be brought back to life, then that makes a better financial sense for the operator to do that and make the most out of that initial investment before moving further. for any replacement. So we were initially thinking, if satellites are going to be deorbited in large volumes, then those are not the satellites which are going to be available for refueling. But as it turns out, and we will wait for Daniel Faber to shed more light on it, that the deorbiting capabilities themselves rely on relevant refueling capability. So without the in-orbit refueling capability, the deorbiting solution itself will have its own challenges. And so it's a trade-off there. So as long as it makes better financial sense for the operator to refuel at a cost relatively lower than that what it might take to replace with a fully functional new satellite, then they are going to opt for it. So at present, it makes better financial sense in the geo segment, and that's why we are seeing more successful use cases in the geo segment. But we do expect the demand to emerge from the LEO segments as well. But so far we have been talking about one refueling satellite going to the target satellite and refueling it. Now orbit fab has a whole new vision of establishing a space infrastructure, a refueling depot which will hold large volumes of multiple fuels, be it from inert gas to any cryogenic fluid, such that that infrastructure can support refueling activities covering earth orbit missions to deep space missions. Now that's more broader and deeper, but it's not as easy as it sounds. There are going to be many challenges. The very idea of having such large volume of dangerous fuels in orbit, and then being able to deliver that to different spacecraft, different grades of spacecraft over a longer a longer time period, itself presents a lot of challenges. How will the in-orbit refueling market counter this? Specifically, how will Orbit Fab counter this? We will be listening from Daniel Faber on that. But we recently published our global in-orbit refueling services market study, and here is a brief snapshot of the numbers. The first year's revenue estimate, that's estimated at 7.5 million. It is expected to cross the 1 billion mark in as little as 6 to 7 years. Now that's phenomenal growth. The CAGR goes well above 100%, and we usually do not see this type of CAGRs in any market. This is an emerging market which just got operational, but given the sheer number of satellites that are deployed in orbit, and the large number of deep space missions, our research so far covers a little over 90 deep space missions, including ongoing and planned missions, and there are many iterations of those deep space missions which by design are going to utilize large space infrastructure, not just in earth orbit but also in lunar, Martian orbits and beyond. There are missions going all the way to asteroids, and there are back and forth missions, some of them looking to bring back surface and subsurface materials. Now that is going to require reliable space logistics, spacecraft that is going to carry material back and forth, and it is these spacecraft, for example the space tugs, involved in actually taking these hardware and getting those space infrastructure installed for the next phases of the deep space missions. Those are the spacecraft which are going to heavily rely on in-orbit refueling, because they are not going to be able to support the deep space mission with just one full tank of fuel. And so clearly with just the satellite market we are seeing such a phenomenal growth, and while the demand seems promising, the very act of doing this successfully, safely, reliably, and while also being financially viable, seems very challenging from our perspective. But there are many participants working on this, and we have Orbit Fab here with us. So we would like to hand it over to Daniel Faber, who can take us through how is Orbit Fab planning to solve this problem, what is Orbit Fab's vision. Daniel Faber, I'll stop sharing the screen. Over to you, Daniel Faber.
So, Daniel, I have already shared the slides that you have shared.
Oh, okay, thank you very much, and appreciate the opportunity. Yes, I'll give an overview of sort of Orbit Fab and where we see satellite refueling going, some of the sort of key aspects of this. I don't know if you're able to put this in present view, but our tagline, gas stations in space, it's not exactly gas. It's not exactly a gas station. The architectures are very different, but it's a useful tagline to communicate to people what we do. So we've been operating for the last 4 or 5 years. We have some interesting strategic investors, including Northrop Grumman, Lockheed Martin, and Munich Re Ventures. The biggest underwriter of satellites and rockets is Munich Re. These types of investors have really helped us to get legs in the space industry. Our goal is to create a bustling in-space economy. If you want all these types of things to be happening in space, if you want to support permanent jobs in space, you really need to have fuel in order to bustle. There's a lot of things that require mobility, and we're currently very constrained by having a single tank of propellant in any satellite system. A lot of that's been talked about already. So slide 3. Like I mentioned, our vision there, our mission is to build that in-space propellant supply chain. That is what we're doing. Slide 4. This is some of the things that have already been discussed in terms of the benefits that you get from refueling, increased revenue potential, also decreased costs when you can shrink the size of the fuel tank, you shrink the actuators and various things. You also move a lot of capital expenditure off to operational expenditure, so that lowers the barriers to entry significantly, such that new business models can be stood up for much less capital requirement, making a lot of new business models then accessible to VC-funded startups, simply because that's the capital requirement right now is so high. That's been an impediment. So there's a lot that will happen once you're able to change the cost structures and cash flow requirements for new businesses in orbit. It enhances mobility, huge gains that we can make, and that enables then, of course, new business models and operations. I'm not going to dwell a lot. That's already been discussed a lot. Let's go to slide 5. Just sort of a view of some of the benefits and how this happens, both reducing costs and increasing revenue potential. There's a lot of math, of course, to quantify these that we have done working with our customers, but this sort of summarizes the various ways in which cost is reduced, especially capital, upfront capital, and then increases the revenue potential by being able to do things faster, get into an orbit quicker to generate revenue, move between orbits without reducing the lifetime of a spacecraft, and then even extend that lifetime or replace the fuel on the initial launch with additional payloads. Those types of things can increase revenue substantially. Moving to the next slide, we see an example. We've run a lot of numbers on this particular example is deorbiting of debris. So there are debris clusters and higher risk objects in orbit that really should be removed. And when we've done the math and talked to suppliers of active debris removal services, what we see is that to remove all the debris clusters would cost about 16 billion. Right? This is a significant cost, and that's without refueling. If there's hybrid refueling, you can reduce a lot. If you have bipropellant refueling and wish to remove all the debris, we can get that down by 80%, down to about 3.25 billion. It starts to become viable as a program, and that's a huge benefit to the space industry and humanity in keeping space accessible to future generations by clearing up the trash that we've previously created. Similarly, with tens of thousands of satellites now being planned and launched, removing any of the satellites that fail out of busy operational orbits becomes more critical. And so while here we've modeled removing all debris, you could imagine that for much smaller numbers, we can remove satellites that are dangerously failed in the middle of operational orbits. So this is important just to understand the scale of benefits that can come when you're able to refuel these types of spacecraft. Slide 7 then, what we see is some of the risks that our customers, we talk to customers that are in the satellite servicing realm, effectively building tow trucks in space, whereas we're providing the gas stations, if you like. We talk to them, we talk to satellite operators. There's some hesitancy to sign up to a refueling contract because of the risks. So Docking activities introduces some risk, but that's the type of technology risk and operations risk that insurance companies are used to. In fact, the Northrop Grumman mission extension vehicles, they carried insurance policies against many of those types of risks. When we look at other risks, though, in the business, for example, supplier power and dependence on a single supplier, these are things that can be mitigated by signing a contract. For example, Orbit Fab will commit to making a delivery of a certain quantity, a certain price in the future through a forwards contract. In return, Orbit Fab needs to cover its risk that we're making a very large investment. And so we have a contract mechanism based on commodity supply terrestrially, which is a forwards contract with take or pay built in, and that guarantees us that we'll have customers when we have made that significant investment and are ready to deliver. There are also risks around fuel price and launch price, and these can go in both directions. So the xenon price right now is extremely high due to demand and to Russian aggression in Ukraine, which has removed some of the supply of xenon. But that price may come down again in future, and that we believe that benefit should be passed on then to the customers. Similarly, launch prices are trending down, so we'd like to pass that on to customers. We definitely don't want them signing up today to a price when their competitors might get a lower price in the future. So we're able, through using escalation mechanisms, to cover our risk that prices go up, our customers' risk that the price goes down, to make sure that they're getting the best deal possible. Also, upfront payments, while we would love to get paid upfront, and some customers have the capacity to do that, for a lot of customers, especially earlier stage commercial customers, cash flow is the most important thing. So by using this take or pay mechanism, we're prepared to make the investment before we receive payment from the customer. We can reduce those upfront payments that are necessary all the way to zero if that is what it's needed to make the deal. One other risk is that now that we have this take or pay contract, our customers could see that they might be stuck with this contract if they don't need it. And so we're able to make these contracts transferable assets. Ultimately, we'd like to see these traded on an exchange, just like commodities are traded on Earth. At the moment, in the near term, we expect those will be bilateral trades. But by making that a transferable asset, it's also something then that the companies we sign deals with, those that are willing to take an opportunity of signing a contract early where we'll provide preferential pricing, they have a transferable asset then that they can carry on their books and sell that to another customer for fuel in orbit that could take advantage of that. And then the last one, there's a supplier reliability. I mentioned Orbit Fab has to cover ourselves after making this investment to make sure that we're actually going to have customers. So we manage all of these risks through contract mechanisms, which means that customers can sign right now up front with very low risk in that contract, and yet getting the assurance that they can execute on their business plans. For example, take the smaller fuel tanks, but know with confidence that they're going to get that fuel delivered. So these are some of the things that we're able to do. Going on to slide 8, just a bit of sort of progress so far at Orbit Fab. We founded in 2018. We flew that same year with 2 test beds to the International Space Station. We used water in this case, tested the pumps, the valves, some of the interfaces. We actually became the first private company to resupply the International Space Station with water. After we'd done all of our tests, we pumped that water into the space station's water supply system. Next slide, what we subsequently did was launch the first operational fuel depot. This is a relatively small depot, a minimum viable product, if you like, but it had the RAFT fueling ports, so they had flight heritage. We were testing thrusters and docking cameras and things like that as well. That's been operating since middle of last year, so about a year on orbit now, proving a lot of the technology that's needed. So these are some of the key things that are building towards our architecture. You can see here we have fuel depots and fuel shuttles. The fuel depots, large tanks of fuel. We get that fuel to orbit very cost effectively, taking advantage of the best deals so we can pass on those savings to our customers. And then fuel shuttles, a dedicated small vehicle to deliver the fuel from a depot to a customer. That allows us to put all of the smarts and all the cost into a vehicle that it uses some of that fuel that it takes from a depot for its own operations. So we get many delivery missions out of a fuel shuttle, amortizing that cost. So the result of this is a very low cost architecture to get fuel to orbit and deliver that fuel to a customer. So that's the keys to it. So stepping back a bit and thinking about where this will go, and some of the sort of near and midterm advantages have been touched on quite extensively. But if we're able to provide fuel and that helps to stand up the whole satellite servicing industry, there are some very interesting and very large opportunities that become available. So once we have large scale construction on orbit with, we say tow trucks offhanded, but yeah, the servicing vehicles can do assembly, maintenance, repair, as well as, we provide the fuel for refueling such structures. We start to have the possibility for infrastructure like space-based solar power to be able to deliver zero carbon emission power to anywhere in the world instantly as needed. That's a $6.3 trillion market, global power supply. Trillion with a T. Similarly, if we look at global telecoms, at the moment there are millions of cell phone towers on Earth. I expect those to be replaced by millions of cell phone towers in orbit that are constantly upgraded, refueled, increased in capability. So not tens of thousands, but millions of these kind of towers will be able to capture the global mobile comms markets and deliver, again, a global capability that can be upgraded constantly. You can deploy a constellation when you don't need to launch satellites. You reduce that deployment from tens of billions to tens of millions of dollars to bring a new service online. So that market is about $3 trillion by the end of this decade. So we're talking some significant markets that can be won by the space industry once there is refueling and satellite servicing. So next slide. Just some of the images of things that we have done so far. We like hardware, we like building things, we like flying things, we like getting heritage and proving to our customers that we can deliver. So with that, I don't know if we're taking any questions here, but that was just a quick summary of where we see the market, some of the opportunities that are going to come about from refueling on orbit.
Sure, thanks, Daniel. Let me share the screen from my end. Thanks for those interesting insights. Now, let's go over. We have reached towards the end of the presentation. Let's go over some key takeaways, and then before we open the floor for questions, for this, I would like to hand it over to my colleague Nilopal. Over to you, Nilopal.
Sure. Thank you, Arun, and thank you, Daniel, for such insights. Like the key takeaways are more in the trillions than the millions, I suppose. So the economy that you mentioned, the volume as well as the value that can be created, that is in process of creation, is quite extra. Like I would say, like beyond imagination for us, because when we see this market as a whole, like we do see the potential, but we like again the numbers is something which we calculate, but again the numbers that we are seeing currently, it is like quite we are quite amazed by it. So now talking about the key takeaways that we see from the overall ecosystem is the number of growing satellites, emerging in orbit servicing, like the complete ecosystem, the future of deep space missions. There are multiple missions, as Arun already mentioned. We have tracked down 90 deep space missions that is in process, or in next 10 years will be in service. Apart from it, the useful, successful use case for the geo orbit is again a very key takeaway for this market. Now, the emerging demand for the LEO constellations, LEO satellite constellation, whether it is for communication or Earth observation, as well as the deep space missions, wherein the lunar missions, the Mars missions are some of the major missions that different government agencies are focusing on, as well as private players are looking after. And the increasing need for the space situational awareness, as rightly mentioned by Daniel as well, to have a clear orbit to operate is much more crucial, so that the viable and usable orbit space is available for the satellites. Because when we are thinking about the space, we think it from a very unlimited resource standpoint, but that is not the case. The viable orbits where you can operate or place your satellite is quite limited, and to keep them clean is very important. So for that specific reason, space situational awareness is quite important, and it is getting that traction or that attention from the government agency as well as the private agencies, and the evolving in-orbit refueling capabilities for diverse end use. The are the major key takeaways. Apart from it, Arun, can you move the slide to the next one? So now talking about the different research plan that we have planned for the year 2022 and beyond that as well. So recently we have published space situational awareness in orbit refueling. You have already saw, we already shown you a glimpse of it. And apart from it, we also published satellite position navigation timing, electric propulsion, radiation hardened electronics, and commercial off the shelf component market. So those are some of the recently published reports. Then we are in currently we are producing reports on evolving deep space technologies, satellite docking, which is another crucial aspect for this ecosystem, suborbital testing services, assessment on emission control for aviation, and fuel management system. So those are some of the upcoming or in production titles that we have. And then apart from it, we are also having upcoming reports that are in pipeline that are list, which is the heavy and medium lift launch vehicle, satellite-based data storage and distribution, optical communication, space carbon fiber, GNSS correction services, thermal protection system, space force assessment, reusable launch vehicles, deep space launch vehicles manufacturing market, solar panels market like spacecraft solar panels, downstream geopestal services, satellite and spacecraft subsystem, and satellite-based IoT market. So those are some of the upcoming reports that we have planned to be that we will be publishing in 2022 and beyond. So now we are focusing on the new space ecosystem, wherein all the upcoming trends or technologies which is yet to be commercialized or are in the initial phase of the commercialization. We are focusing on those topics so that we give a preview of what's to come in this ecosystem. So yes, and for to talk about our platform that we have, the AI-based platform, I would like Arun to take it forward. Arun, over to you.
Thanks, Nilofal. Now, before opening the floor to questions, you might have a lot of questions. We at BIS Research are developing what we are calling as a deep tech knowledge platform, where we are trying to integrate industry experts, from different markets, from different industries into one platform, where they can network with each other, ask questions and answer questions, free of cost. And we will also be there. So Insight Monk, you can look it up. We will our colleague Ahmed will put the link here as we speak on this chat, and you can get the link. You can go and you can log in by yourself. It is all free, and you will be part of many other industry experts. And if you have any questions related to what you are trying to do, it could be about market intelligence or it could be anything. You can post those questions for free, and you can get multiple answers. If we are able to answer it, we will be observing the questions and we will also give our answers, but you can get answers from many other industry participants. So it's more of a expert oriented knowledge sharing platform. That's what we have. That's our vision for Insight Monk, and it is a AI based solution. So along with these question Q&A facilities, the solution already collates from different reliable sources, again at free of cost, different insights from many different sources. So you get a lot of filtered search oriented, so someone does the search on your behalf and the system presents those insights to you, and you can access it for free. And once you register on it, one of our sales colleagues will reach out to you, and they'll be happy to take you through the overall process of how to use the platform. So this way you don't get lost inside the platform as well. So feel free to check out Insight Monk. But that's for the future questions you might have about what we do and what's happening out in your industry or any other industry you might be interested about. But for now, let's open the floor for questions.
So we have one question. I hope Daniel, you will be able to answer it. What is the future opportunities for an in-orbit refueling depot, and who will be the first customers for those solutions?
Yes, the first customers, and as we've been announced, and it was mentioned earlier in your presentation, uh, we've announced a deal with Astroscale, and we've announced a deal with the US Space Force. So we see commercial customers and government customers. On the commercial side, definitely our, our beachhead market is the satellite servicing companies, so tow trucks in space, as we've been calling them. From orbital transfer vehicles to inspection services to life extension services to tugs to active debris removal and deorbit, and then to robotic repair, to assembly. There's a lot of business models that come under satellite servicing, all of which need fuel. And so some of them more than others. So that's our natural beachhead market. In fact, to serve a legacy spacecraft, we look to these tow truck operators to provide that service. They have the complex robotics to be able to work with legacy spacecraft that weren't designed to be refueled or repaired, and so they need more complex robotics and docking. We're also then looking at commercial spacecraft going forward, communications, remote sensing, the commercial space stations that are being built as customers that will be able to refuel directly. And so that's sort of phase two of a plan is to directly refuel all the new constellations and new satellites. So that's where we see it in the short term. And long term, I encourage everybody to look at this opportunity and how it can change fundamentally how satellites are operated and the types of businesses that are viable in space. I don't think I'm smart enough to figure out what businesses are going to be successful. It's like asking someone in 1990 what was going to be successful on the internet, right? It took how many years before Facebook and Google figured it out? It was more than a decade. That I expect we're on a similar kind of threshold here, where we have incredible capability being built with satellite servicing, but the applications that are built on that are going to be innumerable. And we've just got to try a lot of things. Like there's a lot of space for entrepreneurs now to get involved and find the things that are going to be multi-billion-dollar businesses.
So we have another question from Kai, wherein he is curious about how he can book for refueling, and what size of debris do you factor in into your cost estimate for debris removal with or without refueling. So
Sorry, I didn't quite understand the question. If you could repeat it.
so the question is, how can they book for a refueling? Like,
Ah,
what is the method of?
yes, talk to Orbit Fab, talk to our business development team. We'd like to understand where you would like fuel, when you would like fuel, how you're operating the business. We could also give some feedback on that. We have some fairly extensive modeling tools which show the levers we can pull in order to reduce costs of providing that refueling. So at the moment, there is no standard delivery service, though we are converging on some things that work. But it means that we need to do a bit of analysis to make sure that we are able to provide things that people want to buy at prices that work for your business model. So the best thing is to reach out to us, and we can run some modeling and engage in that discussion.
Yes. And apart from it, there is one more question wherein how do you deal with the mitigating debris risk at your depot in space? So that is
Yeah,
another.
that's a great question, and there are different layers to that. One is micrometeoroid and orbital debris shielding. So we shield our tankers against a 1 millimeter debris impact, 1 millimeter object. So that's one part of it. The second part is to make sure that we're complying with all the guidelines or exceeding all the guidelines for removing any tankers that we have in orbit. For example, if we have a depot that's empty, we can remove that from orbit. So there's a small thruster on there. We're looking at placing insurance policies with the active debris removal suppliers. So if we have a failure of any spacecraft, then they can remove that object from orbit for us. So we're proactive in that respect. And then also, we conduct our operations in zones that are considered relatively safe. So we can minimize the consequence of a failure. We operate as low as possible in low Earth orbit, so that if there's any issues, things will deorbit fairly rapidly. We also operate above the geostationary belt, not in the geostationary belt. So we operate in the graveyard orbit. Again, that's where spacecraft are placed out of harm's way when they end their life. So by doing operations in those zones, we minimize any risks. So yeah, we look at it from several different angles.
Yes. And another question coming in is in your perspective, how will the in-orbit refueling services impact the upcoming commercial space station industry, and also will it be a part of space station in future?
Absolutely, yes. OrbitFab's ambition is not limited to just launching and delivering and storing fuel. We intend to become an industrial chemical supply company. So give us 10, 20 years, we want to be taking material from asteroids or the moon that other people are extracting and processing that into air, water, propellant, of course, 3D printer feedstock, minerals to grow plants, you name it. Tell me what industrial chemicals you need. We intend to supply that. So when we talk to the commercial space stations, they're trying to create the in-space manufacturing, research, tourism, entertainment content, like all of those businesses, in one way or another, they require industrial chemicals as consumables. They also produce waste products that we can put back into our chemical processes. So right now we are already licensing technology and starting to develop some of that capability. But it's the whole business starts with most efficient launch and logistics and operations. And especially when you consider the manned systems, the space stations and the delivery of crew, you want the utmost reliability on those launches, definitely when there's people on board. Our payloads, our fuel is much more risk tolerant. We manage an inventory on orbit. We can handle delays. We can handle a small number of failures. So we're able to take much cheaper launch vehicles and to take the opportunities to get large amounts of fuel cost effectively in orbit, which means that then we can deliver consumables, fuel, water, etc., to a space station cheaper by the kilogram, much cheaper than they can deliver the people that want to use those resources. It makes sense to separate the supply chains or the transport for people and the transport for expensive equipment and the transport for, frankly, cheap commodities like fuel. And so that's where our part of this ecosystem really is.
Yes. And one last question coming in is, will there be a universal standard docking system slash solution to enable the in-space servicing in coming next 5 or 10 years?
There's already a standard for the International Space Station has a standard docking adapter that's big enough for astronauts, of course, to pass through between modules. So that exists as a standard that's been published by various space agencies collaborating together. On the refueling interfaces, we haven't got enough experience yet to say that we've absolutely nailed down the designs. You don't want to standardize on something that's not going to work. And so it's a few years away before we'd be ready as an industry to do that. We hope that what we're doing with our Rafty fueling port, that a lot of that becomes a standard because we think that that's the right way for the industry to go. So we'll see how that develops. Almost certainly this is going to evolve into an international standard at some point. And it's just a question of when that becomes mature enough that it's worthwhile doing that as a standard.
Yes. And another question is from the respect of the satellites and deep space mission operators, saying how they are taking up the orbit fab potential, like for the refueling capabilities. What are their outlook with regards to the services that are being provided?
Yes, we see a lot of interest, and the ability to move capital expenditure to operational expenditure really makes a huge difference to the financing of these projects. The ability to reduce cost overall makes a huge difference. So yeah, we see a lot of demand. What we also see is everybody saying, look, here are the things that I care about that you have to prove in order to de-risk using your service. And so that's the trade-off that every satellite operator is making. But at the end of the day, just like rockets have become reusable, right? SpaceX is up to, I think, 14 or something. The suborbital Blue Origin suborbital vehicle was used dozens of times. So at this point, if you've got a rocket company and your rockets are not reusable, you're heading to oblivion, right? You have to have that to survive. With satellites and refueling and serviceability, it's exactly the same thing. If this is not on your roadmap, you're heading to oblivion because trust me, your competition is looking at it and they're building it into their business models and figuring out how they can increase profitability and outcompete you on price.
Yeah.
So yeah, everybody that all the smart players right now are engaged.
I believe this is one of the last question that is there. So will Orbit Fab comply with the open source standards for the in-orbit docking established by Lockheed Martin?
So Lockheed Martin has the Aspen adapter. Um, it has mechanical power and data connections in that. If you look at that design, there's actually in the center an area that perfectly fits the Rafty, our fueling port. Lockheed Martin is a strategic investor in Orbit Fab. Northrop Grumman is also a strategic investor, and Northrop has a docking interface as well that also can incorporate Rafty to provide refueling. So we're building Rafty into all of those interfaces and working with all the players across the industry. That's a big part of our strategy is just to make sure that everybody's got access to a refueling port and that it's the most reliable and most fit for purpose fueling port that we can possibly make it.
Sure, Daniel. Thank you so much for all the answers. And once we are done with this call, all the questions that are there in chat, we will be answering it in much more detail and sharing it in a form of blog by end of next week. So you will be able to see all the questions answered uh, from uh, from the prospect of Orbit Fab as well as our viewpoint from the BIS Research. So over to you, Arun, for the closing remarks.
Sure, thanks, Nilopal. I think you have already mentioned it. So feel free to put your questions in the chat. If your question has not been answered, yes, we will get those answered in the coming days and we will publish it on our social handles, specifically LinkedIn. And if you have any further questions, we would be happy to schedule a call with you and we can take you through the insights at our end. Special thanks to Orbit Fab and Daniel Faber for joining us and co-presenting along with us in this webinar. And thanks to everyone here for taking time to join us in this very interesting discussion. It is indeed a very happy moment for us, to be investigating into emerging markets and really covering a capability which sounds very outlandish, but the fact is it is an operational market as we speak. So wishing Orbit Fab the very best in the future and looking forward into the future of space. Thanks to everyone. Thanks for your time.